A uniformly charged solid sphere of radius r has potential V0 measured with respect to infinity on its surface. For this sphere, the equipotential surfaces with a potential 3V0 by 2, 5V0 by 4, 3V0 by 4 and V0 by 4 have a radius R1, R2, R3 and R4 respectively then. Okay, so it's a very interesting problem here, very much logical also. You can see that uniformly charged sphere of radius r has a potential of V naught on its surface. So on the surface potential is V naught and 3 V naught by 2 is there. You can see this term is 3 V naught by 2. So this 3 V naught by 2 is indicating this term. If you see, this term is saying that uh, at potential at the center of solid sphere is how much? That is 3 V naught by 2. Yes or no? 3 kq by 2r, and on the surface kq by r. So here V naught is given on the surface and here it is 3 V naught by 2. That means R1, I can say that R1 is the center of the solid sphere. Then you can see that 3 V naught by 2. After that this is 5 V naught by 4. So this is some value which is again greater than V naught. So it is interior to the solid sphere. So it is somewhere between center and the surface, this point. 3 V naught by 4 is the outside point because it is lesser than V naught, and V naught by 4 again is the outside point because it is again lesser than V naught here. So if I draw the sphere and try to find out that exactly what are the possible values of the radius here. So suppose this is our sphere and this is the center. Let's say this is the center here. So here potential is 3 V naught by 2 and here potential on the surface is V naught. So R1 is how much? R1 is 0. Now V at R for R lesser than R, we write it as KQ by 2 times RQ. This is 3R square minus of R square. So this is 5 V naught by 4 and KQ by R, we know that's value is V naught. Okay, so I will be substituting it here. VR, that is 5 V naught by 4, and KQ by R I will be writing V naught by 2 times R square. This is 3R square minus of R square. You can see V naught and V naught will cancel out and 2 2s are 4. So we will get here 2.5 R square, that is equals to 3R square minus of R square. So we will get 0.5 R square equals to R square. So we get here R is equals to how much? R by root 2. Okay, so basically this value R2 is how much? R2 is R by root 2. We got R2 equals to R by root 2. Now it is saying 3 V naught by 4. So 3 V naught by 4 is greater than lesser than V naught. That means this point is the outside point, because you can see the potential variation of a solid sphere. Then the potential variation of the solid sphere is like it is maximum at the center 3 kq by 2r, then at the surface it becomes kq by r, and then it is decreasing continuously like this way, following inverse law. Now so here if I write for outside point for r greater than r, v is written as here kq by r. Yes, so v is saying it is 3 v naught by 4, and here I will write kq. Here I will do one thing, I will write kq by r by r like this way. Now writing this I will convert this into v naught, so I will be writing it as a v naught r by r. You can see v naught and v naught will cancel out and you will get r equals to 4r by 3. So this is r equals to 4r by 3. That means this is your r3. R3 is how much? R3 is 4r by 3. We got R3 here. Similarly for V naught by 4, so for V naught by 4, if we try to calculate for V naught by 4, so V naught by 4. So again this is potential for the outer point. So I will be writing V equals to this is V naught times R by R, and according to the question V is basically V naught by 4. Here this equation that I have written from here. Okay, I just directly used it. So here I will be writing V naught R by R, and you can see that R is equals to how much? 4R. So that means R4 is how much here? 4R. Now R1 is 0, R2 is R by root 2, and 4R by 3 and 4R. So it is saying that R1 is 0, R1 is 0. So 1 and 3 is correct here. 2 is not correct because in the question you can see that R1 we have got 0. So this is not correct. Now 2R is lesser than R4. So 2R is lesser than 4R. That is right. So option 4 is correct here. R1 equals to 0 and R2 is greater than R4 minus R3. So if you see R4 minus R3, so R4 minus R3 is greater than basically 2R, and R4 R2 is not greater than 2R, basically it is lesser than R also. So R2 is greater than R4 minus R3, so that is the wrong statement, and the right statement is 3. So the correct option here is 3 and 4.